In this video, we will discuss types of errors in hypothesis testing and difference between hypothesis testing and confidence intervals. Significant tests are useful, but most statisticians think the method is overemphasized in research. A significant test merely indicates whether a particular parameter value in non-hypothesis is plausible. A small p-value tells us the significance test indicates that the hypothesis value is not plausible, but it tells us little about which potential parameter values are plausible. A confidence interval is more informative because it displays the entire set of a plausible value. A confidence interval shows if non-hypothesis may be badly false by showing if the values in the interval are far from the non-hypothesis value. It helps us determine whether the difference between the true value and the non-hypothesis value has practical importance. You need to be careful with your interpretation about hypothesis testing. Do not reject non-hypothesis doesn't mean you accept a non-hypothesis. In fact, you will never say accept non-hypothesis. If you have a p-value above 0.05, when the significance level is 0.05, you cannot conclude that the non-hypothesis is correct. We can never accept a single value which non-hypothesis contains, such as p equals 0.5. A test merely indicates whether a particular parameter value is plausible. Last, a confidence interval shows that there is a range of plausible values, not just a single one. Here is an example. So we have two different researchers conduct two separate studies to test the same hypothesis. Is the p equals 0.5 or p doesn't equal 0.5? The sample size is 400. If we only use p-values, we can say since the level of significance is 0.05, the following conclusion is true. We reject a non-hypothesis. However, for the research B, the p-value is larger than 0.05, so we cannot reject the non-hypothesis. However, if we look at the confidence interval for the data set by research A and B, you will know that the confidence interval doesn't contain p equals 0.5. So you should see how the confidence interval is showing the same conclusion as the hypothesis testing. However, it should be easy to see that the confidence interval provides more meaningful information than the hypothesis testing. Both of the intervals have a lot of overlap in the confidence interval. Last, confidence interval not only can tell us whether we should reject a non-hypothesis or not, it also gives us the plausible range that the parameter values could be. Now let's talk about decisions and the types of errors in significance tests. A small p-value casts doubt on the non-hypothesis being true, because if it were true, the observed data would be very unusual. Since sampling variability exists, decisions in significance tests always have some uncertainty, and a decision could be in error. Type 1 error is when non-hypothesis is true, but the non-hypothesis was rejected. It is called false positive. Type 2 error is when null-hypothesis is false, but you did not reject a null-hypothesis. We call it as false negative. Here is Table 9.5 from textbook, page 419. When null-hypothesis is true, and we do not reject a null-hypothesis, we have correct decision. When null-hypothesis is true, however, we reject null-hypothesis, it is called false rejection. Then we have type 1 error. When null-hypothesis is false, and we do not reject null-hypothesis, it is called type 2 error, the false negative. Last situation, when null-hypothesis is false, and we reject null-hypothesis, then we have correct decision. The significance level is the probability of type 1 error. The probability of rejecting null-hypothesis, even though it is actually true, is equal to the significance level alpha. Significance level alpha, usually equal to 0.05, is the probability of incorrectly rejecting null-hypothesis. That is, committing a type 1 error is 5%. Since we determine alpha prior to the test of significance, we can control for the probability of making type 1 error. 95% confidence interval had a 5% chance of not containing the true population parameter it was estimating. 0.05 level of significance has a 5% chance of making a type 1 error. Recall that type 1 error is rejecting a true null-hypothesis. You could use a 95% confidence interval to come to the same conclusion as hypothesis testing that use a level of significance of 0.05. 90% confidence interval equals to 0.1 level of significance, and the 99% confidence interval equals to 0.01 level of significance. This is example 9.4.1 from textbook. You can pause this video and try to describe the type 1 error for this problem. Type 1 error for this problem is if the committee determines that less than 30% of students will attend. However, in fact, 30% will attend the event. This will be type 1 error for this problem. This decision has potential consequence. The committee reserves a space that is too small. Now try to describe the type 2 error for this problem. Type 2 error is the committee determines there is no evidence that less than 30% of students will attend, but in fact, less than 30% attend the event. The potential consequence of this decision will be the committee reserves a space that is too large. Here is another example from a textbook. You can pause this video and describe the type 1 error for this problem. Type 1 error for this problem is the researcher determines that the concentration levels are too high when in fact they are safe. The potential consequence of this decision is people are not allowed to fish in the river when it is actually safe to fish. You can pause this video and try to describe the type 2 error for this problem. Type 2 error for this problem is that the researcher determines that the concentration levels are not too high and it is safe to fish when it is really not safe to fish. The potential consequence of this decision is people consume contaminated fish.